So, hello,
Hello.
I am with Professor David Ingram, one of the creators, the main creator of openEHR. So, Professor, what's your story? Like, where did you start?
Where did I start?
Yep.
This is quite a long story, but I started
All the time.
in theoretical physics at the University of Oxford, and my tutor wanted me to join his research group, but I decided I wanted to move more broadly than physics. I probably wasn't good enough to do theoretical physics as a career, and I wasn't that motivated. But I did pretty well in mathematics and theoretical physics, and I got into industry through a bit of a circuitous route of linking up with an industrial scholarship to pay my fees at university, and from there got involved at quite senior level in a multinational engineering group and saw many different major projects like major development of ships and other kinds of engineering and the people leading those big projects. And so I got quite interested in major complex projects and decided to there in that group go into their medical engineering side. For one reason or another, I traveled the world with them and got involved in quite major projects in the Middle East and other countries. But it wasn't really going anywhere in the sense that the kinds of challenges there. I wanted to get more involved with medicine and its healthcare challenges. A bit about my own background in living in the social care environment in my childhood, etc. My family very much involved my father in social care services across the UK. So I switched, and I already had a pre-established scholarship to go and do a PhD in a subject which I was for my choice, really. And I got into the world of mathematics in the context of biophysics and did a PhD in that arena of looking at how to model human circulatory and clinical physiology systems, and got a job in the medical physics arena in the very early era of many computers from the Digital Equipment Corporation, for example, in Boston, coming into the medical world, very immature technology that we had to sort of very hands-on kind of approach to it. We were really engineers and programmers and scientists all in one in that kind of era. We had to do it all. So we did learn a huge amount about machines and the way they function. And out of that, I became known in the era when medicine was beginning to wake up to the impact of computers in this whole arena, with a very far-sighted clinical researcher, very expert in his field of hypertension research, John Dickinson, very connected internationally. And he became a professor of medicine. And he decided he really liked working with me. We'd done some useful things together. And he said, how about coming with me as a founding member of my new department in this very old established university in London, St Bartholomew's Medical College, established in 1123. So quite a well-established place, and not any particular place for me to land there other than this newfangled discipline of linking the computer with medicine. So that's where I started. Was that your sort of question?
Yeah, I mean, and again, when was this? So when you were at the department of, when you headed the department's IT efforts, what time was this?
Okay, so I'm 79 today.
Okay. You don't look it. You don't look it. You look much younger.
I don't feel it, but I am.
No, I saw you dancing. Yeah. Yeah.
Anyway, so so I studied physics at Oxford in 1964 to 67. I worked in industry for a couple of years, did my PhD, and I got my first academic post, which I've just described to you as a lecturer, in 1975. And that was where we really set sail to try and do all this modeling. One of my principal lecturers of Oxford went on to head the UN climate change panel, John Houghton, and he actually died from COVID a few years ago, very sadly. But the latest ICPC report was dedicated to him. He taught me the whole principles of atmospheric physics in my course at Oxford, and the modeling that all flowed from that into weather forecasting today. So I had a really good sense of complex systems and data sensing environments and how from that you work out patterns of weather and turn that into forecasts of weather.
Yep.
And we were naively thinking this was a sort of a model approach that we would take in clinical physiology. And I won't go into the detail of that. We built a whole series of programs in circulatory system dynamics, in respiration and gas exchange, in body fluids and electrolytes, and drug kinetics, drug pharmacokinetics. And we took all of that out, went to 1,000 institutions around the world. And this was mainly in the educational side. And on parallel with that, I looked at it with colleagues I worked with. Could we use that in clinical medicine? Would it help if we had a model like that to marry that with the actual measurements in intensive care of complex problems of respiratory management? We looked at that particular aspect. And I spent 4 years doing quite complex mathematical approaches to matching the predictions of a simulation model with the actual clinical data, collecting all of that data with mass spectrometry and things like this. Pretty highly intensively instrumented intensive care environment. And what I discovered, I mean, we worked with people I mentioned in my talk yesterday, working with Arthur Guyton, who was the primary medical physiology guy who really got to grips with the computer in analyzing circulation. And basically the end of the message there was that the data environment was not conducive to the same kind of mathematical and modeling approach that you might use successfully with the weather system. The weather is the weather, the physics of the components, and they are common. Whereas in medicine, context is all. And so that was where I sort of came to the end. It got me a chair, which you need to do. But I decided, I needed to move in a different direction. So again, that took me forward. That gives you a timeline up to the time that I met up in Barts with Sam Hurd and with people who wanted me, as I became a professor, to take on some wider roles. I worked for the Wellcome Trust in sorting out some difficult issues they had in tropical medicine, education, and computer resources for that. I worked with the Marie Curie Foundation to produce a whole series of interactive video discs, which were nationally profiled on cancer patients and their families at home. I did a number of projects like that spread me out into the wider world of healthcare. And it was a nice way for me because it sort of connected my own social background and interests with something where I had something pretty original to contribute and which people seem to be interested to listen to and get involved with.
So you said that in physics, it's easy to model data because there is only a few data points, right?
It's not easy to model. It's feasible and tractable to model.
Right.
In that domain, if you have the capacity to sense an instrument in and around the key ways in which behavior evolves and is patterned. So you have to have the measurement and the data closely coupled with the way you model. And sometimes a very simple model in certain problem domains will do better than a highly elaborated model. And, I discovered all of that alongside working with different groups. That, for example, if you want to regulate the infusion of a drug that's controlling blood pressure, a very simple model will do a whole lot better than a very complex model of all the interactions going on. Do you see what I mean? So you have to have this patterning of the data environment and its context alongside the problem domain and what you're trying to solve.
Right.
And that was feasible and tractable and massive investment, massive amounts of physics in the weather forecasting. And, so I knew all of that from knowing John Horton, he taught me, etc. But in the context of medicine and clinical care, it came to a bit of a dead end there. I'm not saying it's forever a dead end. If you compartmentalize the problem space, there's a lot that's happening in the virtual physiological human world and things of this kind, where they've learned their way through to, as it were, marry the way they model alongside. So this digital twins and so on and so forth is, I think, evolved. Peter Hunter and Dennis Noble, people I knew at Oxford in my time there, because they were working on modeling cardiac metabolism and things of that kind. Peter Hunter's now with Corey in Auckland. Well, Corey's with Peter Hunter in Auckland. And so the digital twin and Peter Coveney at UCL, who I knew quite well, they're all sort of trailblazing in that arena still, and they're getting to good places with it. And AI, very interesting story of AI in the context of weather forecasting, which maybe we shouldn't go into here. But I mean, the message at the moment is certain problem spaces in weather forecasting are better handled by AI than they are by the complex weather forecasting models that we have looking a week ahead or 10 days. If you want to know what's going to happen in a very short period of time, an AI will get you a more specific answer.
Yeah, no, for sure. When exactly did you come across this thing that can be described as a precursor to openEHR?
A precursor.
Yeah, when did you
1989.
And like what did it
happened?
look like?
Okay.
What did
it look like?
What did openEHR look like?
Okay, in those days. Okay.
Yeah.
So there was the Niels Rossing, I mentioned about him and the way the European Commission set him in motion to do a program of advanced informatics in medicine. Part of that was working towards an idea, no more than a scoped idea, of a common architecture of healthcare data in medicine, basically. There was a call for proposals, as happens with major bidding. I mean, I've worked across research councils a lot in all the different domains of science and practice of medicine in later years, but the European one was where I got most of my funding. And what we did, Sam Hurd had been producing a system for primary care in the East End of London called Paradox. And he, in that, got to know a clinician, an oncologist in Belgium, in Brussels, Alan Maskins. It's all written in my brief history of GAIR and openEHR.
Yeah.
You know, I recorded that history as eyewitness stuff, you know, along the way. I'm not reinventing this in any way. And that was a part of the purpose of my book, to put all the eyewitness stuff together there, because otherwise it would have been lost. But anyway, so where I came to it was Alan and Sam were interested to put a consortium together, and they had various industry partners. Alan Maskins was already running his own company. He'd given up on clinical medicine and oncology for a while, and he established a company called HDMP. And he had a product called Health One, which had begun to characterize the classification, itemization of the components, small components of clinical data in records. Okay, he called them health record items, I seem to remember. So what Sam asked me to do was to come to a meeting of that initial consortium group, and then it evolved into, would I lead the proposal? So I worked with Alan and Alan mainly, Sam also, to propose a project which looked at issues of portability, comprehensiveness of the clinical space, the requirement side of it, and then putting that into early prototypes. And so that was the project, the GAIR project. Alan Maskins called it the Good European Health Record, and that's where GAIR came from. And there were some very powerful players bidding for that space, as you can imagine. I won't go into the detail of that. I put a little bit of it in the book, but fortunately, our proposal, maybe because it came with a bit of academic pedigree from my side, and with Alan's really already emerging. I mean, one of the great things in this space is you have to have something to start with, to incrementally experiment with it, see where it falls short, to improve it, and so on and so forth.
Yeah.
And having the HDMP product was both a blessing, but it was also a bit of a sort of a difficulty, which I'll explain in a moment. But it enabled us to persuasively put forward a well-segmented project proposal for several million EQs, as they were called in those days, euros. And we won.
Wow.
And the world was very upset. Who are these people?
So who were your major competitors back in the time?
There were a lot of industry people who were linking up with a group coordinated by somebody. I'm not going to quote names here, okay? But people who had been pulling together industry people. There were different consortia. One was called Reach. There was Nucleus. You know, there were other groupings. I mean, there was 3 or 4. Actually, I get to the stage of my life approaching 80 when I have nominal aphasia. So I can see the people in my mind's eye, but I can't always connect the words.
Okay.
So I don't remember all of those names.
All right.
But nonetheless, there were, and going back 30 or 40 years, IBM's been there, DEC's been there, ICT have been there, Siemens have been, all these big companies have all thought that the healthcare domain was something that they could productize and bring IT, even though the IT technology was oodles less mature than it is today.
Yeah.
But I mean, the internet has changed everything. Incidentally, Tim Berners-Lee followed me 6 years later at Oxford to do physics, and his dad was somebody who sold me one of my first computers.
Really? So your Tim Berners-Lee's dad sold you your first computer?
He came to we didn't actually buy it, but so we tried to sell it.
Amazing. So when you talk about okay, so you did this new thing, and there were existing players like the big ones, IBM, Siemens, and and then you won, and this new approach won. What changed really? Like what was the perception like?
Okay, so I think the thing that was very different, that it was very strongly clinical requirements focused. In other words, a lot of the early work packages were about systematizing requirements.
Okay.
Because there are many different granular levels of requirement, from the very personal one-to-one to the more organizational and then population levels. And the data needs to be credible, tractable, and relevant and meaningful across different spaces. That's not to say all the data travels all the spaces, but it shouldn't be warped, biased, and noisified, in ways that can easily happen when you don't have a grip on data. If you don't have a grip on data in weather forecasting, you won't have a good weather forecast. You can easily get to a situation applying what look like rigorous tools to noisy data environments, where all that you talk about confidence limits of predictions and things like this, where the confidence limits go out, and you end up with you're not going to be terribly impressed as a clinician to say that the probability that this patient has this diagnosis and should be treated this way lies somewhere between 0 and 1. But maybe that's a slightly esoteric point to be making, but you see what I mean, that the confidence of the predictions relate to the qualities of the data.
Of course.
And
so I mean, data is much more critical in that decision making than, like, let's say, weather forecast, right? Like, for sure.
Yeah.
But how did you start justifying this open platform or an open approach, as opposed to a proprietary vendor just coming in and saying, like, hey, you know what, we'll do everything for you, and we'll take care of the data quality?
Okay, so remember that the vendor space was in a very different era there. I've been through 5 eras of replacing data in institutions that I've worked in. So I know all the travails of how data is lost from implementation to implementation. So the uni-vendor kind of thing wasn't really promoted in the way it is now with the big money. But nonetheless, that is an important point. What we did in this project, because obviously we worked very hard, and I've recorded in chapter 8.5 of my book, some of the results of that early stage of it, because that isn't actually present elsewhere at the moment. I've got the documents. I mean, I've got the biggest archive of the last 40 years. So the IHT-SDO guy was asking me about the history of the relationship of openEHR and SNOMED. And they said, do you keep the record? Well, I've got the whole of the record of the 2 years where we tried to get them aligned. And I'm probably the only person in the world who's got it.
Okay.
But, so my archive, is pretty extensive across that domain. And we got to the end of the exploratory phase, I would call it. I've sort of recorded all of this in the openEHR space, on the website as well. But then you see in the academic world, you then have to get another grant, okay? And Sam had decided sort of quite early on in the GARE trajectory that he and Meredith, they decided they'd take the family back to Australia. So he was commuting to and fro. I recruited Thomas Beale into the group in London from the Royal Marsden, as I was explaining yesterday, which is where, in my world, two-level modelling really took off, because the whole of that product of Joe Milan in the context of the Royal Marsden Institution and the value it derived was based on a very systematic modeling approach, where he had what he called clinical object dictionary, and the clinical objects existed in, I mean, this could be such a long conversation.
No, it's fine. We have all the time. We have all the time.
Yeah,
And
okay.
so you met Thomas Beale, and
well, no, Joe introduced me. He said, Thomas is working with me as a consultant. I was looking for somebody who could disrupt a lot of the channel thinking that I found, because I was a bit new to some of these folks, but I was me, okay? So there was a bit going on here, and I don't want to be, I'm not in any way critical or anything, but there was a bit of channel thinking because we had an initial product, HTMP's Health One. Alan Maskins is thinking very much channeled the way, and he was a strong and influential and much to be respected in this. But there was a bit of a clash of perspectives that came in and around how much should it really evolve from there, or should that be an example tried out and then another iteration in a different space perhaps. So there was some resistance even in an exploratory group to move away from something that people were reasonably confident about. And that was if you have a requirements driven approach, you have to go where the requirements take you. So I needed a little bit of new thinking and object orientation, Bertrand Meyer, all of the stuff that Tom knows so well, Eiffel, all of that. I was sort of interested to bring some of that thinking into care, and that was my role, you see. I mean, I'll tell you a joke. There's a saying in Poland, I'll say it in Polish, "Nie ma sześć kucharek, nie ma co jeść." And the translation is, where there are 6 cooks, there is nothing to eat. Okay? And I translated this to, and this is just me operating in this space, which is clinically led. And I turned that into doctors and opinions. And so where there are 6 doctors, there are 7 opinions, I think. Okay.
It's really funny you say that, because I had Jordi tell me this exact same quote, and then he told me how nowadays that may not be entirely true, because people are starting to standardize the process that doctors can come up with. Okay, that's the next best thing. But funny.
Well, that's right the way back there. So I was interested in lateral thinking. Lateral thinking, and it was essential, really. So that was my guy to come, and I appointed him into the group, and I wanted a bit of stirring. He was a very good stirrer.
Thomas.
Thomas. Yeah. So, and Joe and Thomas. Joe is just, he's just such a principled and tough and capable guy. His staff always says there was no task he gave them that he couldn't have done better himself. That's saying something, but it was true of him. So that was how that happened. And then as things were evolving, and Sam coming to and fro, and Thomas there, and I was working in the academic department of general practice, which Leslie Southgate was leading. So there were a lot of doctors. There were 5 doctors, as I say. So it was, in my case, where there are 5 doctors, there are 6 opinions, whatever. But it's a bit of a joke. But one of the reasons I was put in charge of clinical skills in informatics, because they didn't want to put it purely in the doctor clinical domain, nor in the nursing domain.
Right.
And so I had a bit of that role in care to, okay, you've got these technical people working in different informatics companies, and you've got all of this clinically driven perspective, but we've got to have something to eat, okay?
Right.
And so that was a little bit of my balancing responsibility, because it wasn't short of all the innovative ideas. Sam was absolutely amazing. One of his great strengths in all of this is that, and I've seen it with John Dickinson with the modeling of clinical physiology. I've seen it with Bill Aylward with Open Eyes. These are clinicians who master sufficient of the technology, and you're much the same, where they can bend it to do what they need, and they will break rules around it because they know where they're trying to get to.
Right.
So if somebody, schooled in resilient, reliable coding might say, well, you've gone completely wrong here, and you should have structured all this in a much more data-friendly kind of environment. But that's not the point. You can do that at a certain stage, and you need to do that at a certain stage, but the innovative stage of it, that's not the point.
Yep.
Octobana, exactly the same. we exchanged code between us, Octo, and he showed me a lot of code he was doing on fluid and electrolyte management. I showed him MacP and MacPuff and all that stuff we were doing. And we'll put it sort of kindly, two-level modeling, it certainly wasn't his code. His clinical knowledge and everything else to do, it was all sort of in there. So I had a good sense from having worked with people like Octo and then seen the power of mumps. And Joe absolutely doted on mumps. And I mean, Octo solved a very difficult problem in the context of sparsely filled arrays and how you analyze and process them. Yeah. So that was how, that was where we were in the middle of that. And out of that, my sort of perspective, we were getting follow-on projects. We built Joe's two-level modeling into our next project in London. We call it Object Dictionary. It's called the Synapses Project. It's all described there. And Sam had Thomas come back to join him in Australia, and they worked on something they called GARE Australia, or can't quite remember what they called it. So they worked away, and then we were sort of apart for a year or two, and then we came back together at a big meeting in London and decided that we were pretty well on the same pathway. Sam had really worked out the archetype space better. And so we sort of decided we wouldn't go with Object Dictionary anymore. We would all align it. And Deepak was working with me. Deepak Kaura, he's my PhD student. He was one of my early clinical appointees, came with me to UCL when we were appointed there. And he got interested in the ISO side of things and spread off into that domain. But so I had Sam, Thomas, Deepak, they were all part of that umbrella, along with people who became presidents of Royal Colleges. Leslie became president of Royal College of GPs. Jane became the president of Royal College of Physicians. It was a great career accelerator for those two. But it was an amazing sort of crucible of activity, and all dependent on having a vice chancellor of a university, and before that, professors of medicine who just, for me, just gave me tremendous freedom. And what I really, I suppose, brought to that stage was helping it to get somewhere with something to eat, representing it in the big speeches to European Commission and big meetings and so on and so forth, and the slides that would try and communicate what we were trying to do, and actually then thinking in terms of, okay, so this is my experience of what's happened with multiple generations of data that's gone down the plug hole. As I was saying yesterday, trillions of dollars over the years. Really, it's very easy to make the case that trillions of dollars have gone along these.
Because they kept switching different vendors, and the data goes into a black hole.
And there was and everything ran out of funding streams on the academic side and industry side. Products didn't work or whatever. Industry went bankrupt, couldn't cope. All of that stuff. The healthcare bore the brunt of all of that. I mean, it's been a very difficult journey for healthcare. But we all know that it's getting it right is central, and the way you get things right matters as much as what you do. And that I suppose that was, the principles. I wrote the original openEHR manifesto, the way we would move from where we were to an organization that would have participation of all these different interest groups in and around a common core of what we would do by way of the the organization, and that was really, I think that was a pretty important stage to say we're going to have to put this all into the public domain, Creative Commons. Talked quite a lot about the open domain in my book, haven't I? So that concept of the kind of organization, I wrote the original terms of reference of the Architecture Review Board and the Clinical Review Board, which never really got going. And, it was all embryonic, could have worked, whatever, but I still had my livelihood, my place, the university. I was having to do big jobs for the university just to be allowed to carry on to do that stuff. But I had lots of good allies. And as I said yesterday, alliance is absolutely key in this. You've got to have safety around your allies. And I had a vice chancellor who was really prepared to let me there. But he had his own expectations, and deans had their expectations. So they were merging 3 medical schools, very, very high-powered clinical research into Great Ormond Street, the Institute of Neurology, all the Cancer Institute, all of those different institutes, and they all had their own IT communities. They all had their IT service companies, groups, sorry, and they all wanted to stay alone. They wanted the money and just do their own thing. This is a human paradigm.
Yeah.
And the university couldn't afford that. And how do you get all of those people? And they had tremendously powerful people saying, we're different. We need this money in our space, and we'll do it our way. And we want a separate email server. We want a separate this and a separate that. And we want to run it 24/7, that sort of thing. Hopeless. And my job was to get all those teams together, to find common cause, and to marry them, because the central department, there was a central department running HR and library and all of that sort of stuff. My job was to marry that very sort of determined community that was going to keep all these people in order.
Yep.
And they would have destroyed a lot of good stuff if they'd done it their way. And if we carried on that way, that wouldn't have worked either, because this mattered as well.
Yep.
My job, I had to chair the infrastructure committee for the whole of the university, the billion-a-year turnover university, sit on the executive board there. Whenever they needed to put something into the health service, they nominated me. So they put me on the London Modernisation Board. They put me on the boards of the different trusts that were linked. There were 7 NHS trusts, separate organisations, all linked to UCL in that way. The Engineering Physical Sciences Research Council wanted me on their board. The Medical Research Council wanted me on their board. So I was busy, but it gave me the freedom.
Yeah.
So that was my life, really.
This is the overarching theme here seems to be that healthcare wants to localize. Like they want to have their own way of doing things, and each department or each sub-department wants to, do things in their own certain way, right?
And they have a very good argument in saying, we're just going to do it the way we do the consultation with the individual patient. It's special, which it is. And they metaphorize that up
Right.
to sort of make that separate to the whole system.
Right. So, I mean, the whole reason, I think the idea behind openEHR, if the essence, if it may, is that you separate the data, you separate the data models, you try to separate the workflows, you separate everything else, and then you have this common base or this common ground on top of which you can then feed these workflows and these data models in.
Yeah,
right?
Absolutely. But you can manage them independently and incrementally.
Right.
Within that concept. And then the overall governance then matters hugely, because you've got to have the right people in the right place. And extending this into the sort of beyond openEHR to open care, I think is really significant now, not only because of the multiple devices that everyone's going to have in their own homes. I mean, I don't know if you've ever read Ivan Illich, Medical Nemesis.
No.
1970s. Read that book.
Okay.
It's all about his project. He was a very anarchic
Medical
kind of
nemesis.
Nemesis, yeah. He also wrote Deschooling Society. So he's a very radical social kind of engineer who wanted to get rid of all the schools because they were harming people's education. And he proposed a solution before the internet, which looks very like the internet. So it's, now you look back at it, you say, oh, well, it's just radical kind of stuff that was, not very far-sighted. But he had a similar thing for medicine, where he said, I foresee a future where the only stuff that medicine will do will be stuff that the patient can manage in their own hands. Very radical. Okay.
The patient can manage in
their own hands. Yeah.
Okay.
The technology that actually could be operated. Read the book. I'm paraphrasing it quite significantly. But that was. But there is that trend.
We're getting there.
We are heading that way.
Slowly getting that way. I mean, like the glucose monitoring machine.
Yeah.
And it's able to deliver a dosage.
And so in relation to chronic illness, that is absolutely that we need, just like I'm talking about low-cost prescription glasses.
Right.
Nobody's going to afford £700 glasses. We've got to have a means and a vector to get to them anywhere on the surface of the world to do what I get from these glasses. And you need similarly with management of chronic illness.
£700 for glasses? That's how much it costs you?
Yeah.
Really?
Ridiculous, yeah.
Okay, fine.
This is Essilor. You're responsible.
I mean, we can get glasses for less than £1.
Yeah.
In India.
Yeah.
But yeah, I mean, coming back to this argument of, medicine and healthcare will be something that the patient administers to themselves, and then they are able to be this agent of, they take full control. I mean, we're seeing a trend towards that, right? Like we're seeing more and more patient control. But why though? Like, why do you think that's the argument to be had? What's wrong with a patient going to a surgeon and getting diagnosed and having surgery done to them?
Nothing wrong at all. There is an issue of choice
Right.
that not everyone is going to be an e-patient, Dave, going into that level of detail over their own management. They don't want to be there, but other people passionately do want to be there. Okay,
Right.
and they're both right,
Right.
because it's personal choice.
Yeah.
However, in the terms of how you organize services, you've got to make sure that you can accommodate diversity. One of the big problems, I think, of this whole space is that because machines are actually, relative to living systems, they're very inflexible. Okay, you have to follow their rules, and they either work or they don't. You know, I'm paraphrasing, but they work or they don't work. Whereas the human body is very much more adaptable to sort of going up and down in phases of coping and not coping and adapting and putting itself right and all that stuff. It's a very organic thing. Yep. And we need I've talked about this organic care information utility, that it's going to have much more input and interplay with the individual experience and patient, but it needs to be seen as an organic entity and not fixed in the way that IT systems often have to be. Right. And so I think we've got to have that kind of context of an organic utility, which flows like water. You know, I've said, it flows like water. But it's much more complicated than water, even though water is pretty complicated as well. You look at it in detail. But anyway, so we do need to sort of think in that way to evolve to something which has got the wider care dimension there of engagement of patients alongside professional people. Because at the moment, we're getting into a lose-lose situation. Two of my children are front line of clinical services, and daughter-in-law is GP, so we've got a lot of that experience. And then we all experience medical services, don't we, in one way or another, particularly when you get older. But so, I've sort of, everyone's got that experience, and we can see that there is a lot of lose-lose going on at the moment. And Topol was talking about that in his book. And we've got to find our way back to win-win, where we're not making a choice between, I mean, quite honestly, there are many aspects of healthcare services for many people which are much better handled in the specialist domain, obviously. So I don't know whether, well, what do you feel about all of that?
No, I think, we're heading towards a whole new world with AI, right? And the ability for it to just quickly model what you want and then get it done. It's almost like the amount of flexibility that is needed in a system is kind of now possible, right? I just think the whole industry and the clinical domain will probably not be limited by software. They're still going to be limited by how they think about workflows and how they think about managing the thing, right? And I mean, I like to think that you can only standardize data as much as you can standardize the process around healthcare.
Yeah, because the data has to fit.
Yep, the data has to fit, and the process has to have a proper way to feed the data into the system.
Yeah, but be adaptable and to evolve in time.
What's been your take on that? Like, how you've seen a lot of health systems, and do you think there is a trend towards process standardization, or are we becoming more and more diverse, and are we becoming more and more localized in terms of process?
It's sources for quarters. I mean, you remember ATLS? Okay, Advanced Trauma Life Support.
Okay. Yeah.
Which was protocol driven. You rave in an A&E department, they follow a very rigorous protocol, because the evidence is, unless you do it that way, you will harm patients, because the immediacy of the situation, how the actions need to be quick. It's better to follow a pretty rigid protocol rather than, what have we got here? A very sort of open, and you may well miss things, but overall, an ATLS seems to be the right way. And so there are many aspects of skills and practice which follow routine in that way. And those have expanded. I mean, Atul Gandhi looked at all of that in the Better, his books on healthcare improvement.
So you think it's going more and more towards process standardization? And
I can't say whether it's going more and more. I think it's horses for courses. Where that is advantageous and shown to be advantageous, it should go that way. Yeah, I think. But I wouldn't like to put it as an absolute principle, because the conditions in which healthcare is delivered and can be delivered, and the possibilities, so variable according to local context and local requirement, local culture.
Right.
That's stuff we're going to take a long time to adapt to and evolve. We've got to hope that we keep the IT agile, to be a good partner along the route, bringing good things which are there. But to say as points of principle, we should head for this particular technological solution, whatever, I wouldn't. I read Topple's book on artificial intelligence, and I know the origins of all of that. I mean, for me, it's a slightly misleading umbrella term, artificial intelligence, because I know the mathematics of everything and where it's come from, and I see the way it's used and described in sort of more journalistic context, which is a little bit far from the underlying reality of what is being done, because people use it to exemplify their own imagination in a way. And I call that Imagineering. Well, that's not me, but there is a bit of that goes.
Sure.
But we don't want to miss any of it.
For sure. I think it's changing. It's AI is now a vague term, because like machine learning, deep learning, now Gen AI, everything is AI.
And some of it's just basic statistics.
Right. Do you have a copy of your book? I mean, we can show it to the audience, and
Not here. I haven't got it here. I've given away my last.
Okay, so you signed all of them.
Well, yeah, I said 4,000 downloads.
That's pretty good.
Yeah. Well, it's nice that people can get to it. I mean, it's a long book, and it's not something that people will read cover to cover. Phil Colchin told me he'd read it cover to cover. It took him 2 months. And there are a lot of people who've talked to me like that, but a lot of people will just dip.
Yeah.
But it's like that. It's a song line.
Right.
So it's from an early stage, all the precursors, philosophy, mathematics, computer science, how they came to be, how they encountered medicine, what happened with technology, etc. And then looking forward in the third part of the book. So have you had a look at it?
Yeah, I did take a look at a few of the chapters, and it's I think you cover the history of things really well, and the footnotes and the references are just like brilliant. It's very vigorous, if I have to put it here. So,
but it has to be there. You can't just have slapstick academia in there.
Yeah. So, David, thanks a lot for
is that all right?
taking the time. Yeah, this has been really good, and I'll put a link to your book in the description down below. So if anyone wants to check it out, they can download a free copy. Is it?
Yeah, it's free copy.
It's a free copy of the book. Yeah.
The book you have to pay for. It's printed on demand in 3 places around the world.
All right.
But it's a community interest company publisher, and they're in the top 100 of community interest companies in the UK. So they're lovely people. And I can tell you something, that they are based in the humanities mainly, and they chose my book, because it's humanities context, I think. But believe you me, their copy editing is the most rigorous I've ever found. You might think that these literary people, they would not allow a single quotation who didn't have a verifiable citation.
So check it down below. Buy a copy if you would like to support the organization. And yeah, amazing. Thanks for taking the time.
Thank you.